Welcome to Star Chat, the podcast that takes you on a journey through the vast expanse of space and time. I'm your host, Carl, and I'm thrilled to have you join me on this cosmic adventure. Today, we're going to explore some exciting news from China's space program. Get ready to blast off into the unknown. As we speak, China is preparing to launch its next space sample mission, Tianwen-2. This ambitious endeavor will mark the country's first attempt to survey and sample an asteroid, putting it in league with spacefaring nations like the US, Russia, and Japan. The mission is slated to launch at the end of May 2025 on a Long March 3B rocket from the Xichang Satellite Launch Center in Sichuan Province. The first target for Tianwen-2 will be the asteroid Kamoalawa, a fascinating object that's estimated to be between 4,100 meters in diameter. What makes this asteroid so unique is its status as a quasi-satellite. It orbits the Sun, but its current location near Earth means it also loops around our planet. Astronomers believe Kamoalawa may be a boulder that was blasted off the surface of our Moon, following an impact with another space object. The Tianwen-2 mission will employ a touch-and-go technique to sample Kamoalawa's surface, using an extended robotic arm to scrape the asteroid as the probe flies past. If successful, it will mark the first time China has collected samples from an interplanetary body in our solar system. The probe will then continue on to its secondary mission, exploring the comet 311P Pan-STARRS in the main asteroid belt between Mars and Jupiter. This mission is a testament to China's growing presence in space exploration and its commitment to pushing the boundaries of what we know about our universe. As we delve deeper into the mysteries of space, we're reminded that there's still so much to discover, and missions like Tianwen-2 are paving the way for future generations of space travelers. As we explore the vast expanse of space, we're not just expanding our knowledge, we're also inspiring new generations of scientists, engineers, and explorers. The thrill of discovery is a powerful catalyst for innovation, and it's exciting to think about what other secrets our universe holds, waiting to be uncovered. We'll be right back with more fascinating space news on Star Chat. Welcome back to Star Chat. We're diving into the fascinating world of exoplanets, where the rules of our own solar system don't always apply. Today, we're exploring two intriguing discoveries that are challenging our understanding of planetary formation and orbital dynamics. Imagine a planet orbiting between two stars, its path weaving through the narrow space between them. This is not just a scenario from science fiction. It's a reality in the new Octantis system, where a pair of stars hosts a retrograde planet, moving in the opposite direction to one of the stars. But that's not all. This planet's orbit is also unusual because it's stable, despite the close proximity of the two stars. This discovery was made possible by years of observation and improved measuring devices, such as the HARP spectrograph at the European Southern Observatory's 3.6-meter telescope in Chile. The persistence of the planet's signal over time has convinced researchers that this is a real planetary body, rather than stellar activity or other phenomena. But here's where it gets even more interesting. One of the stars in the new Octantis system is a white dwarf, which means it has reached the end of its life cycle and become denser and smaller. This complicates the history of the system, as mathematical models suggest that the planet's current orbit was impossible when the star was younger and larger. So, how did this planet end up in its current orbit? Did it form from the mass ejected by the star as it transformed into a white dwarf? Or did it radically shift trajectory after the star's transformation? These are questions that will require further observations and modeling to answer, but they highlight the complexity and diversity of planetary systems beyond our own. And if you thought that was mind-bending, consider another recent discovery: a polar orbiting planet in the 2-mass J15 104,786, 281,1874 system. This planet orbits between two stars at a nearly 90-degree angle to their orbital plane, a configuration that's been suspected but rarely observed. These discoveries invite us to consider a wider range of star and planet scenarios regarding formation and evolution. They remind us that the universe is full of surprises and that our understanding of planetary systems is still evolving. As we continue to explore the vast expanse of the cosmos, we're reminded that there's always more to learn, more to discover, and more to wonder at. Stay tuned for our final story of the day, right here on Star Chat. Welcome back to Star Chat. I'm your host, Carl. As we conclude another fascinating episode of exploring the wonders of our universe, let's take a journey to the outer reaches of our solar system, to a world that has captivated human imagination for centuries: Saturn's moon, Titan. Titan, with its thick atmosphere and lakes of liquid methane, is a place like no other. It's a world where the skies are perpetually shrouded in a thick haze, and the ground is hidden beneath a layer of icy fog. But despite these harsh conditions, Titan remains an intriguing destination for scientists and space enthusiasts alike. Recent discoveries have shed new light on Titan's mysterious atmosphere. Using data from the James Webb Space Telescope and the Keck 2 telescope, scientists have detected convective clouds in the northern regions of Titan, a phenomenon that has never been seen before. These clouds are responsible for producing methane rains, which replenish Titan's lakes and seas. But what's even more fascinating is the discovery of a missing molecule, called methyl radical, which was previously undetected. This molecule is formed when sunlight or energetic electrons from Saturn's magnetosphere split methane molecules apart. The detection of this molecule provides scientists with a unique opportunity to study chemical activity on Titan as it happens. As we continue to explore Titan and its many mysteries, we're reminded that the search for life beyond Earth is an ongoing and fascinating journey. Will we eventually find evidence of life on Titan? Only time and further research will tell. But one thing is certain: the discovery of methane rains and convective clouds on Titan brings us one step closer to understanding this enigmatic world. As we conclude today's episode of Star Chat, I want to leave you with a sense of wonder and awe for the vast expanse of our universe. From the majestic rings of Saturn to the mysterious landscapes of Titan, there's still so much to explore, discover, and learn. That's all for today's Star Chat. Remember to like, share, and subscribe. And until next time, remember to keep looking up at the stars.